Hi and welcome back to DACAscript. So today we're going to be going over sparse columns. Now sparse columns have been around for quite a while. I think it's SQL 2008, which is where they first appeared, but we're going to be having a look at it from a SQL Server 2016 angle. This video is going to be split into two different sections. We're going to go first through kind of like presentation, go through the finer details of sparse columns, what are they, what restrictions they have, etc. and so forth. And then the second bit we're going to be doing a lab where we go into SSMS and we actually play around with the different T-SQL commands, set up sparse columns, and we're also going to have a look at the space. So if you guys are just interested in the physical, how do I do it in terms of the T-SQL, then I will put a link in the description of the actual time points. Just click on that and it will zoom you across. If you guys are doing the Microsoft exams or preparing for them, I would definitely advise going through both sections of it and practicing as well, because it could come up. It's one of those things. So first off, what are sparse columns? Well, sparse columns are actually a specific column which has got optimized storage for null values. So it's actually at the storage layer of SQL, and it stores them slightly differently. And because of that, it's perfect for nulls. So imagine if you got a column which has got 5% of actual data and the rest of it is just completely blank, then you should probably be thinking about a sparse column if it's huge. You know, if it's a huge table which has got millions and millions of rows, definitely start thinking about it. So it reduces the space requirements for nulls at the expense of an overhead to retrieve non-null values. So as always, we've got a trade-off with these kind of things. You know, you get a new feature come out, or this one's not new. You get anything that comes out really is always going to have a downside to it, but there is ways around that. So getting at your non-nulls is a little bit more of a performance hit. It's not massive though, and it actually requires more space for non-null values as well. Another thing that is a little bit different. So yeah, it's going to require more space. Now the reason that is because it actually does it as some sort of stores it in XML in a way. So as you know with XML, or should know with XML, if you have a null, you don't even have to show it. So you don't actually have to say, you know, say requires is the field. You got requires, then the data inside it. Then you'd have close requires. Essentially, is what you get. If it's null, you don't have to put it in there. So that's where it's actually getting savings from, and that's why it's also taking up more space, because you've actually got the field name in there as well. So it can be used with column sets. Now column sets are essentially computed XML on sparse columns, so very, very strongly linked. However, we will be going over that in a different video, because there is quite a bit with column sets that are more specific. Most people just use the sparse columns as they are, just as a storage kind of optimization, and don't worry about the column sets. However, if you guys do, I will be covering that in another video. Another thing that they're really good with is filtered indexes. So filtered index is exactly what it sounds like. If you haven't heard of it before, it's an index which is filtered. Nice and simple. So imagine you've got a column which has got 5% of non-null values. You set up a filtered index and you say where it's not null. Well, now you've got a really small, really lean index that's filtered, and then you've got the actual kind of like really good winning on your optimized storage for your null values. So you then get your speed benefits back. So there we go. That's how you're going to get around the whole overhead to retrieve non-null values if you've got a nice filtered index on the actual values that you're kind of looking for. Awesome. Woohoo. Excellent. So Microsoft actually says that they can that you should consider using sparse columns when the space saved is at least 20 to 40%. Their documentation is absolutely brilliant on this, as it normally is. If you go onto the main page for it, they actually do have a table which splits it up by data type of where you should be looking, how much you can save, etc. and so forth. It's really good, so it's a brilliant reference. If you're thinking about doing this, have a quick look on there. It'll give you even better facts on that, but that's the general 20 to 40% saving if you get that. You know, when the space is being saved at least 20 to 40%, then you should consider it. Then you should think, actually, do we need to do this? Is this kind of like the trend that we're going on? And that's the, you know, having a look at your analytics is really important to kind of like figure it out going forwards. So there's a couple of data types that it can't be used with, and I'm just going to put them all here. So we've got geography, geometry, image, n-text, text, timestamp, and user-defined data types. One that might catch you out in case you guys have got any user-defined data types. For whatever reason, sometimes you just do it just to keep a kind of like a standard going through your entire application. You might have actually set up a user-defined data type and said it's actually just varchar 10, and this type of value that we use, the code type value, will always be less than 10. So, or not really less than 10, up to 10 characters. You might actually set up a user-defined data type for that. can't use it with sparse, so that's something you need to be aware of. However, if it was in that case, it's almost always going to be populated if you use like a code to link tables together, maybe. And also file stream. I know it's not a data type, but file stream type pointers, they also don't work with it, which makes sense really, because your file stream, you're most likely using it in the case of file stream with a lot of files. That would be the main kind of win of using it. So a couple restrictions. As we know, there's always restrictions on these kind of things. The column must be nullable. Well, that makes perfect sense, and that's Microsoft documentation for you, stating the obvious. And it also cannot have the row, GUID, curl, or identity properties. Kind of makes sense, especially with identity, as you've probably seen. Identity is used to have like an auto incrementing integer, so you might use it for primary keys. Well, in that case, you are not going to have a lot of nulls in there, so it doesn't make any sense to actually have an identity on something that that you're expecting to have lots of nulls, and therefore you want to use sparsely. It just doesn't really add up. A bit of common sense in there, really, but it's worth mentioning. Other thing, of course, that's common sense: cannot have a default value. So that is an actual kind of restriction on using sparse. But again, it makes sense. You wouldn't want to have it, default to X or whatever it is, I don't know, or not known or not specified or something like that. Well, you're not going to have a lot of nulls in that table then. So this is a bit of an interesting one. A computed column can contain a sparse column. Okay, so a computed column can be made up of multiple sparse columns. As I said, the column set type thing is basically a computed column of sparse columns, so it kind of makes sense. That's all the other things to kind of remember. However, a sparse column can't be computed because it's at the storage level. You have to have the physical data there and then. It can't be dependent on field 1 and field 2 to make this computed field 3. That does make sense, but it's something to be aware of. Another thing, data masks. Now, I've talked about data masks before. They can be defined on a sparse column, but not a sparse column that is part of a column set. Okay, so if you've got a column set, you can't have a data mask on it. So, yeah. Again, we'll talk about that in that column set kind of video, I think. And again, a sparse column cannot be part of a clustered index or unique primary key index. However, both persisted and non-persisted computed columns that are defined on sparse columns can be part of a cluster key. Something really specific that Microsoft has put in their documentation. I mean, that is really specific, really, but yeah, something to be aware of. So if we continue on with these, sparse column cannot be part of a user-defined table type which are used in table variabled, and I think it's supposed to be variables, which are used in table variables and table valued parameters. Okay, so that's another thing you need to know about. And another thing that's really important, probably the most important out of all these ones, well, maybe, except for the common sense ones, you can't compress a sparse column, which kind of makes sense, I guess. And so you can't add a sparse column to a compressed table. So that's something you need to be aware of if you've already got a sparse table, already got a compressed table. You can't do that. And you can't compress a table with a sparse column. So this is where you might have an issue. You might be looking at your table going, God, we really don't have any hard drive space. For some reason, your company is on a really tight budget. That happens all the time these days. And you've already compressed the column tables. And you're looking for other ways, and you come across this thing called sparse columns. You can't use the two together. Real big shame, but yeah, you can't use those two together. So be aware that you have to kind of choose which one of those two is going to give you the most benefits. That's why UAT type environments, a separate box, is brilliant at, because then you can actually grab some of that data, even if you have to skew it a little bit for data protection type reasons. And then you can at least have a look at it, or you can just look at numbers. You can just generate data on the fly. So be aware of that one. Another thing to be aware of, there is an in-memory overhead for updates to sparse columns. So they need an extra 2 bytes. Now, I'm pretty sure this is due to the XML type way that it gets stored. But again, something you need to be aware of. So how does SQL manage the non-sparse to sparse kind of process? Because, of course, it's at the storage level, so it does have to do a couple things. So what it does first is it adds a new column to the table in the new storage size and format. Then for each of those rows, it updates and copies the value to the new column. It then removes the old column, and then it rebuilds the table if there's no clustered index, or it'll rebuild the clustered index to reclaim space used by the old column. So that's just the kind of process that it goes through to actually do it. Another thing that I haven't actually mentioned here about sparse columns is usually you have a column limit on each table. At least of 2008, I haven't got the more recent facts. You can actually have 100,000. So in 2008, you could have 1,024 columns on the table. However, sparse columns, you can actually have 100,000 extras on top of that. So it didn't add to that count. I'm pretty sure it's very similar in 2016. I couldn't find the facts really quickly. But it's another thing to be aware of, that if you've got a big table, you can actually use sparse columns to extend it. If you've got some never-ending table where you just got loads of different config things, lots of noughts and ones or null and one, very simple, like permissions type thing, where you've for some reason not done it in a repeating fashion, instead you've done it in this giganto table type thing. You could have done for a legacy app, something like that. So there we go, something to be aware of. So SQL Server Technologies that support sparse. So transactional replication, we will be going through that in some videos. So it does support sparse columns, but one thing you need to be aware of, it doesn't support the column sets as well. So that's another thing. You'll find a lot of these, they'll actually support sparse, but won't support column sets. But yeah, again, we'll go over that again. We've also got change tracking. So that actually supports sparse columns and column sets. So there we go. So that's something to be aware of. And we've also got CDC or change data capture. So that supports sparse columns but doesn't support column sets again. So a bit of a different thing. So that's it for that kind of like presentation bit. Let's get into SSMS and we will get on to some examples. Okay, so here we are in SSMS. So what we're going to do, we're on my kind of like test instance that we set up before. I've dropped my database, so I'm actually going to create one. So what I'm going to try and do with these videos is make sure that if you haven't actually gone for any of my ones before, then you can actually start from scratch. If you already have got the YouTube database or YT database, then great, you can use that. If not, there's your create command. So we just created the YouTube database. We're now just going to use YT. It's nice and easy. I like that it's quite small. And the first thing we're going to do is we're going to create a table. And what we're going to do, this table is going to have, let's say, ID, which is an int, and we're also going to have identity on it. I'll spell it. Identity, column 1. We'll go through all these type of things in another video, I think. And it's also going to be our primary key. There we go. The next one we're going to have is like a full name type of thing. So we're going to have some employees. Oh yeah, that's what I should call the table name. Create table employee. First field is going to be our ID, our primary key. We're going to have full name of the employee. That's going to be varchar. Actually, it should really be nvarchar if we're thinking about it. Yeah, nvarchar 100, and it's going to be not null as well. We're going to put that kind of like constraint onto it. So let's go through a scenario. So we've got an employee table. We've had it for a long time. We've had quite a few employees. And then what the boss kind of was thinking about really early on, or at least when we brought in this system, they want to start asking a couple questions with the employees, such as something like, I don't know, favorite food. Let's go favorite food, something like that. And we'll just go varchar 100, and it's null. So they've got favorite food, and they've also got something like favorite color. Let's go color. Now I'm from the UK, so we spell color that way. That's why it's different. I know that a lot of Americans are going to be going, no, it's wrong. But of course, it's right for us anyway. At least with this OUR. I don't know why it's so different. I don't know why I've got it like that, and you guys got it like that. But whatever. So what we're going to have first, we're just going to do it on the table create just to practice that. You always have to put the sparse keyword in front of a null. So there we go. Like that. It always has to be in front of the null. As soon as you do, or as soon as you try it behind it, it'll go red. So it doesn't like it. So good old IntelliSense telling us something's wrong. So make sure you put it in there. So yeah, the idea being, they've been capturing this data. They've had loads of employees over the years, thousands and millions of them, whatever. And then suddenly they've brought in a new system, and they've got these new things, and they're only going to be asking new employees. So expect it's going to be quite small, something like that. Maybe it's not a great kind of example, but it'll do. So if we just run that query, that will create our nice little table. We should also not with TSQL, I have to refresh everything. We should also see in tables here. There we go, got employee. Cool. And also if we're having a look on columns, you'll notice something in column side, which is this sparse keyword. So we actually get the sparse keyword in there. Something to be aware of, when you actually do select top 1,000 rows, our favorite food column isn't there. So it's not included in that first select. However, I can tell you it does exist. So we get onto there, we do our favorite food. Run that, there we go, the column's now there. So it's one thing to be aware of, definitely. Alright, so we've already got that, that's good. So let's do just insert into this employee table. We're going to do values. And actually what we do need to do is we do need to put in the actual columns itself. So let's just separate these out. So we do need to put in full name. Because we've got that auto incrementing number, we actually don't need to put in the key, which is nice. Favorite food. And what's going to have favorite color. Okay. So there we go. Tom Apple. Nice and simple one. And then null. And null, this is one of the... This will be the owner. We're going to have Tom Apple as an owner this time. Or now, I guess. So let's just run that one. Cool. Tom Apple's in there. We're going to have Jeff. He was another one. He was Tom and Jeff. They made it. Then we got Amanda Orange. Sounds very weird. Amanda Orange or something like that. And, I don't know. Laura Pearface. It'll be different. Got to have fun with these examples. So they've been doing that for a very long time. Literally basically just had full name. Brought a new system, like I said. They migrated that data in. And now we've got a new employee. And as part of that, they need to be asked these favorite food and favorite color questions. So this person is Jane. Go with Jane Fiji. I'm going to go with something completely different. So our favorite food is pasta. Really, really basic. And she likes red. So there we go, got that in there. Cool. So let's just do a select star from employee. Now, one thing you'll notice about select star does include those sparse columns, so it only hides them weirdly. So it really only hides it on that select top 1,000. I don't really know why. I think it's something to do with like a kind of like hidden keyword. I'm going to find out at some point, but I'm pretty sure it's part of the temporal tables type stuff. But anyway, we've got this kind of table here. And we've got mostly nulls on that one, and we've got one that's not null. So there we go. There's a nice example. Really, really simple. How have we forgot to do something? Ah, no, because people do forget stuff. We forgot to actually have this favorite color field having a sparse kind of like keyword on it, or the sparse storage format, and we know that it is. So how do we actually do that? Well, it's really easy. Really, really easy. So we actually do alter table as you would expect, employee. So nice and easy stuff, and alter column, because that's what we're doing. And we're going to alter the favorite color field. Spelled wrong for me, but for you guys, sorry, no, spelled correctly for me, wrong for you guys probably. One thing I'll notice, you have to put in the data type, as you might already know, because well, we are editing it. We're essentially dropping it and recreating that column, but with the data in it. Well, SQL does it for us, which is great. And we would just have the null keyword, but remember we have to put in, if we're doing a sparse, we'll put it in front of it. There we go, so then we get that. And if we refresh this, there you go, you can see the sparse there. And we could select star from employee. So we can have a look at this quickly. And we can see that's in there. Well, what is actually going on if we do some update statements? So if we update, and we set favorite color. Now I'm not doing very good at putting the table names at the minute. If we just update employee, we're going to set the favorite color equal to blue. So they've suddenly put out a questionnaire. Everybody's answering this question now. So we're going to go blue. We do 3 as blue, 2 is yellow or something. Let's just for some examples here. So we've got yellow there, and we've got black for 4, something like that. There we go. So run a couple update statements. Sorry if I'm going a bit quick. You can always pause as well, but these are nice and simple update statements. So if we just select star from employee again, So look at that. So now what's happened, we've got loads of data in that field, so it's no longer really getting that sparse kind of benefits, and you can have a look at SP space used, by the way, for it as well. Let's have a look at that if you wanted to. So we can actually have a look at how much data has been used and all that kind of stuff in here. It's really good when we actually do a comparison, and we will be doing a comparison in a minute where we're going to bulk load a table with quite a few thousand rows, I think about 500,000 rows or something like that on 2 different tables. And then we'll have a look at the actual space used for each of them, one with sparse columns, one without. So it'll be quite good. So there we go. So that's what we actually get. We can see that there's quite a bit of data in there, etc. and so forth. So what we need to actually do is we need to remove it. It's really easy. I'm going to get rid of that. I want to do everything from T-SQL without having to look at it, because that's what you should know most of these for the exam anyway. Though if you're not doing the exam, just look them up on the internet. It's great. So we're just going to do alter column employee, and then alter column. Zoom in fort favorite color. Sorry. Ugh. Not doing very well. Alter favorite column, and that was a varchar 100, and it is nullable, so we're going to keep it like that, and you just leave out the sparse keyword. That's how you remove it. So when we run this now, you can see the sparse kind of stuff has gone off of it. Cool. What we should have done is kept a record of this table and had a look at the space saving on it. We'll do all that stuff, I think, in the next bit, but that's literally how you create a table with a sparse column, how you alter a table with a sparse column, and add the sparse kind of setting in there, property is the right word, there we go, property, and also how you remove it. It's really easy to remove it. Just make sure that you're obviously looking at your data types, and you can either do it obviously through here or also through really good store procedure, SB_help is really good as well, if you've not used that one before. Really good SB help as well, because that'll then give you all of these really good, absolutely amazing for finding foreign keys and stuff like that. I can see the keys. Oh, I didn't give it a name. I wish I'd given it a name, but since it's not live, I hate it when it just auto-generated ones in production. Absolutely hate it. I always want to name them, so I ended up dropping them and recreating them and all that kind of stuff if I do it. But yeah, anyway, at least you can see it in here. Apparently we're 200 for the length on there. No, I can't remember that, but oh, we did 100. Oh, God knows what's going on. Oh, it's the extra bits. That's what it is. Of course it is. MVARCHAR. So yeah, that's that. So part 2 of this is going to be basically creating a couple tables from AdventureWorks. So that's what we're going to do. So we just clean the slate here. Actually, I'm just going to completely just get rid of that. We don't want to see any of that old data anymore. We're also going to drop employee, actually. Should have done this first. Now, obviously, you can just do drop table employee, or you can right click it and do delete. I recommend practicing your T-SQL as much as you can, even with these simple commands, because it just helps with, in general, just doing scripty type stuff. And if you ever have to do any work as well, scripting is just makes your life really easy, especially repetitive stuff. So what we're going to do is going to have a look at AdventureWorks. So if you guys haven't got that already, AdventureWorks is just a Microsoft database that you can download, you can restore it, and it's pretty good for examples. This isn't the samples one, this isn't the data warehouse one, this is just the normal one. I think it's AdventureWorks 2016 STL or something along those lines. In my installation tutorial I do go over how you can restore it. It's really easy. But yeah, it'll work with any kind of data really. This is just for an example. We're going to have a look at the person.address table. So if we just open up that, what we can see in here is address line 2. Let's get rid of this select top 1000 actually. What we can see in here is address line 2 is pretty damn sparse. It's good though. It's weird. It's like I've already looked through this table and found ones that are sparse. So that isn't the sparse column. So what we're going to do is going to put basically copy it. We're going to copy all the data. We're going to do it a couple times. We've got 19,000 rows, so we're going to do it 5 times. We're going to copy the same data 5 times into there, just for the sampling. Going to put it into one which has that as a non-sparse table column, and one that's sparse. Nice and easy. So how do we do it? Well, let's just close these. So we're going to let SQL do the work for us, the heavy lifting, and we're just going to right-click on the object. We're going to go script table as, create to, and new query window, and I absolutely love this. It just makes your life so much easier. I'm going to scroll out a little bit. I have scrolled in quite a bit for quite a few different things. One thing I'm going to do is go up to the top. I'm going to use YT, our YouTube type database. And the other thing is I haven't got the actual schema called person, so I'm going to get rid of that. I'm going to keep this address ID, integer identity, all that kind of stuff. I'm just going to remove the not for replication. We don't need to worry about that. But that's it, really. We don't care about anything else. The rest of the stuff down here is a load of like constraints and defaults and extended properties. Goddamn everything. We don't really care about that. So we're pretty happy with this. We're going to use YouTube. We're going to have it in the DPO schema. That's what change we made. Wiped out everything else, and we've removed that not for replication. You could leave it in there if you wanted to. There's no reason why not. And that's it. We're just going to run that command. Cool. There we go. That's worked. Excellent. Not that we expected it not to. We're then going to do address underscore sparse this time. So we're going to call it sparse. We're also going to have to rename this constraint. So we're just going to put sparse. It really doesn't matter what you actually put in, to be fair. We're going to leave that there. The only thing is, address line 2, that's the one that we thought looked very, very sparse, and we could do obviously some stats on it, but there's so little data that we didn't even need to. We just saw there was. So we're going to make that sparse column. So sparse table has got a sparse column. Cool, makes sense. Knock that onto there. There we go. We've got 2 tables now. Let's have a look at that. Cool. So if we just go to here, open it up, there we go. You can see address, columns. You can see that address line 2 is not sparse, but the address line 2 on the address table is not sparse. Address sparse table, address line 2 is sparse. There we go. Really simple. So what we're going to do now is we're actually going to go back into AdventureWorks, back onto that person address, select everything. There we go. Let's grab this data here, and we're just going to grab it as is. Go onto a new query. We're going to do insert into first. I'm going to switch into YouTube. So switch into your YouTube database or whatever your test database is. You might call it something else. Insert into address. Now, one thing we're going to have to do, because we had that primary key type thing, we're going to just have to edit the actual fields that we're putting in there. So make sure you put that in there. Get rid of address ID. Yeah, nice and simple, that one. But get rid of address ID. I like to move everything. I don't know why I like to do this. I know that a lot of people like to have it like, open like this. Where you can actually view it and actually have the comes underneath it. I don't. I'm going to do it because I think it's actually clearer. So it is actually clearer. And then put that in there and put that in there. So there we go. So we're going to just have address line 1 to city, blah, 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 blah. Basically let that key just do its thing, really. And because it's saying that it doesn't like it, I'll put it in square brackets, but it's absolutely fine. And with that select statement, all we're going to do is remove that address ID. And remove that. We've got that there. Really neat trick. If you have a Go, now Go usually separates out bits of your script. You can put a number after it. So you can actually do 5. We're actually going to do 10. I'm going to do 10 this time. I'm going to make, what was it, 19,000? So it'll be 190,000. Going to do go 10, and what that'll basically do is it will go, alright, do that from there, do that. How many times do you want me to do that? Okay, I'll do it 10 times. Pretty simple, really, isn't it? Nice and easy. There we go. Let's play that one through. I'll play that one through. Let that one go. And look, beginning execution loop. Batch execution completed 10 times. Awesome. So that's bulk loaded that table. So let's do it again. This time on the sparse one. So sparse this time, okay? Let's have a look at this. Exact same. I'll change the thing 10 times. Cool. There we go. We've got that in there. So just in case we've inserted into the wrong table, let's just have a very quick click and have a quick look. Remember that that sparse column is hidden from that select top 1000. If you guys use this as much as I do, I just use it randomly. Then you'll see stuff missing. But we can see that that data is in there. See that there is a lot of it as well. Well, if we take off the top 10,000, because I'm not really, it's obviously not production, so I'm not going to be loading all that data into RAM. It doesn't really matter. There we go. 190,000 stuff. So, well, how does it actually compare? How does the data compare? Let's just close a couple of these. And how do we actually have a look at it? I did show you guys earlier, very, very quickly, actually. Here we go. Right, so new query. We're going to do sp underscore space used. And the first one is address. Now you have to put in a go if you're going to do multiples of these, otherwise it just doesn't like it. It thinks you're giving it arguments. Or at least I think that's what it's doing, but I'm not too sure, you just can't do it. And then put in this sparse, there we go. And we go, shove in a go, let's be good. So we're just going to do those obviously once. And we're just going to have a look at these, there we go. So what have we got? Let's just this one up, so there. Same amount of rows. Reserve space is different, so we've got more reserve space on the non-sparse kind of table. Actual data-wise, we've got less data in the sparse one. Yeah, that's good, isn't it? And then index size as well, same. And, well, we could expect that to be the same because we haven't done anything with the indexes. We've not done a sparse on the index or anything like that. Anything strange like that. And unused, there's more unused and there's less unused than that. Okay. That'll be something to do with the reserved, I reckon. So what happens if we fill up address line 2 on both? Because we need to do both. Right, so if we just do an update statement, we're just going to do it on address. I'm going to set address line 2 equal to mumbo jumbo. Because that's what we do. So that's literally what we're going to do there. Address. I was doing that. Let's do sparse as well. There you go. Run those. So now they've got full data in both. So how different is it? So what we've got, this is something that I don't get. Same amount of rows. Reserved again is more in the address table. Data-wise, it's more in the address table. And then the same kind of thing. More unused in this one, less in that one. So it's not that different. Not in the grand scheme of things. I don't know if it would be if we did something like null. We can have a look at null as well. So null to null. Null against null. We're going to do it sparse. I think that's all gone. And just do it as normal. And let's have a look. What do we get? Let's have a look. It's really easy to compare it. Wish you could just do it in a nice grid together. Probably could. Yeah, you could script it, but I can't in a minute. So again, more data in address, less in address sparse. So there we go. That's kind of proof. Nulls don't take as much space up. But like I said, it's not that big. It's not that big at all. So guys, that's it. Hopefully you've enjoyed this video. If you have, comment, like, subscribe. If you've got any comments at all, please do post them below and I'll see if I can answer them. If not, well, good luck on Google. No, I'll point you to the right Google pages to actually go at if I can't answer anything. If there's anything you guys want to see, please do comment it. But that's it. I hope you've enjoyed this video. If you have, comment, like, subscribe, and I'll see you guys on the next one.